Hi guys. Okay, talking mainly to period one here. There's only one thing I haven't done with you guys that I was able to do with period two, and that was this last example. Now, the wording of this is horrible. Determine the points, the tangents to the curve are horizontal. So there's actually no English working sentence there. So determine the points to the tangents to the curve. Determine the points the word we need is where. Determine the points where the tangents to the curve are horizontal. There you go. Okay. And so I've got this interesting looking combination function here. I think I'm going to deal with it as a quotient rule. So I'm going to look at it as this. I'm going to take the derivative of the top. So it's going to be 2x. I'm going to times it by the bottom. 2x squared minus 1 to the 1/2. So that's the derivative of the top times the bottom. Subtract the derivative of the bottom, which is 2x squared minus 1 to the negative 1/2, because it's 1/2 take away 1, times 2x. So now that whole thing is the derivative of the bottom times the top. And so it's going to be 2x, and 2x squared minus 1 to the 1/2. 2 here, the 1/2 here and the 2 here will cancel each other out. Minus, need a bracket, minus x, x squared plus 3, and a 2x squared minus 1 to the negative 1/2. Now, continuing our philosophy from class, I'm going to take out the largest negative, and that's going to come out. So I'll take an x out, and I'll take out a 2x squared minus 1 to the negative 1/2, square brackets, and I'm going to be left with a 2. That came out. That. Now, the question I ask myself is, what do I have to multiply 2x squared minus 1 by to get 1/2 when I multiply it by negative 1/2? And the answer is 2x squared minus 1 to the 1. So that when this comes out and it multiplies, it's going to be 1 minus the 1/2. It's going to be the positive 1/2. And then the x came out, and I'm going to be left with negative x squared plus 3. And this whole thing came out as 1. So there we go. So now I've got x, and I've got 2x squared minus 1 to the negative 1/2. And inside the square brackets, I've got 4x squared minus 2 minus x squared minus 3. So now I'm going to have x, and on top I'm going to have 3x squared minus 5. Let's see, that's 3x squared minus 5. I have a feeling I did something wrong, but I'm not sure. X squared minus 1 to the 1/2. And that's going to be set equal to 0. Now, these numbers are different than what I had before, so I'm going to go back and check. So, unless I just did a different question on the board. So the derivative of the top is this, times the bottom, subtract the derivative of the bottom, times the top, all's good. Then I'm going to put these puppies together. I'm going to take out an x, I'm going to take out the negative 1, so that comes out. That's nice, and I'm left with negative still, and that makes sense. And okay, period 1 may have made a mistake on what we were doing, I'm not sure. Period 2, I'll have to take a look tomorrow. So anyway, notice that we want where the tangents are horizontal, so that means that the slope of the tangent is 0, which means that the derivative gets set equal to 0. So we're going to set equal to 0. So it's going to be x, 3x squared minus 5 over 2x squared minus 1 to the 1/2. Talking quietly. So now, what I like to do is just put that over top of 1, because it could be 0 over any number. You might as well make it 1 and cross multiply. You'll notice that you'll be left with x, 3x squared minus 5 equals 0. And this is going to be multiplied by 0, and it's going to be gone. The other thing to do is a logic statement, in which case you know that only the top is going to matter for getting to 0. The bottom can be anything at all, in which case you'd say, therefore, x equals 3x squared minus 5 equals 0. So then from here, you're going to say either x equals 0 or x equals plus or minus root 5 over 3. So again, this isn't jiving with what happened in the other class, so I'm going to have to go back and check. But so far so good, and we'll go on from there tomorrow. All right, guys, see you tomorrow.